In Leslie-Gore model, the carrying capacity for predator population increases linearly with density of prey population. However, in this study, we assume that the environmental carrying capacity for predator populations is influenced by both prey and predator population. So first we have assumed that carrying capacity for predator population Kp is proportional to the abundances of prey population, that is Kp equal to small k into x, and now we assume that this k equal to capital K into lambda function of y, that is we assume that this Kp capital K lambda y into x, that is dependent on both prey and predator populations, where k is the proportionality constant. Using this functional form given in 2.2, which previously discussed, we obtain the following extension of the system. So now dx dt becomes r0 minus r1 to r2 into xt, and this become this form into xt, and this become this form, that is first it was y by small kx plus m0. This becomes this term for lambda equal to lambda 0 n plus lambda 1 y divided by n plus y, and this function was lambda y divided by 1 plus h lambda x. So by putting the value of lambda, which is this, we get this system 2.3. So now we incorporate the fear factor affecting reproduction of prey population, and for this we follow Sorkar et al., in which the author have proposed that the following functional response to reflect fear of predators. So by plotting this function, we see that for k equal to 0.1 the curve is this red, and for k1 equal to 0.1 this, and for k1 equal to 0.3 the function become this curve. So from this we see that this function is monotonically increasing function as k1 increases. So this indicates that the reproduction of prey population increases. Reproduction of prey population increases due to the value of k1 increases, which indicates that the birth rate of prey population increases due to heightened fear levels, which is a contradiction, biological contradiction. Okay, biological contradiction, as prey population avoids predator population generally. So we assume another function. So this inconsistency shows that the heightened fear level k1 leads to the increased energy expenditure on anti-predator behaviors, resulting in higher fear cost and reduced prey reproduction rate. To address this, we assume the function for fear factor which affecting the reproduction rate, where eta 0 represents the saturated fear cost, k1 denotes the strength of fear induced by predators, and by plotting this we see that the value of this function decreases due to increasing value of k1. So this shows that for increasing value of k1, that is heightened fear levels, leads to the decreases in pre-birth rate, so which is a biologically valid. So we choose this function into our model. Incorporating this fair function into our model, we get this system 2.6